A cochlear implant, or CI, works by electrically stimulating auditory nerve fibres from within the cochlea. Using fitting software, the implant is programmed by adjusting electrical stimulation parameters to deliver audible and comfortable sound to the user. Pulse width, maxima, and stimulation rate are three of these programming parameters which affect the intensity and frequency of electrical stimulation. Let's review how these parameters work, starting with pulse width. Cochlear implants convert acoustic sounds into electrical pulses to stimulate auditory nerve fibres. Each stimulation pulse is rectangular in shape, with both a negative and positive phase of equal charge, making it safe for electrical stimulation of neural tissue. The pulse width is the duration of each phase in microseconds, and between each phase is a short period of no stimulation called the interphase gap. Cochlear implants can encode signal intensity by adjusting both the amplitude and the duration of the stimulation pulses. These parameters are set by default for different implant types to optimize efficiency, but in some cases may need adjustment in the fitting software. For example, you can increase pulse widths to deliver loudness using less current when needing to keep comfort levels below compliance limits, or increase them to reduce rare instances of non-auditory side effects like eye twitching. But it's important to keep all the pulse widths the same in the map, even if only some of the electrodes require a change. When changing pulse widths, remember this may affect the other two parameters, maxima and stimulation rate, to maintain optimal stimulation and sound quality. Next, let's investigate maxima and why they matter. When listening to complex sounds, such as speech, some acoustic elements are more prominent and carry more information about a speaker's voice and emotion. Rather than stimulating every electrode, Cochlear's default coding strategy ACE uses maxima selection to identify and stimulate channels with the greatest amplitude for speech and the best signal-to-noise ratio. Research has shown that using the default of 8 maxima gives the spectral richness needed for good speech understanding. Using 6 or less maxima is less optimal and should be avoided. It's important to note, changing maxima can affect the pulse width and stimulation rate used in the map. The fitting software may at times reduce the maxima below 6, typically when longer pulse widths are used. At these times, it's recommended to reduce the stimulation rate instead to preserve sufficient maxima. So let's take a closer look at the final programming parameter in the trio, stimulation rate. Stimulation rate refers to the number of electrical pulses on a given electrode, delivered every second to the auditory nerve. A 900 Hz rate is a commonly used stimulation rate across many implant types, although research has shown that rates as low as 250 Hz are also sufficient for speech perception. While stimulation rates above 900 Hz may deliver information more rapidly, there is a limit to how fast the auditory pathway can effectively process what is heard. In fact, clinical studies have shown that using lower rates, such as 500 Hz, gives comparable speech perception outcomes for most recipients, with the added benefit of power and battery life savings. CI programming is an important part of delivering optimal outcomes for recipients. So remember the golden rule of the parameter trio. Increase pulse widths first, then when needed, lower the stimulation rate next, keeping maxima above 6.